Welcome to Sleepster, the place where science dreams gently and time forgets how to hurry. Before we begin tonight's story, take a deep breath and let the day fall behind you like a coat you daren't need anymore. Tell me, where are you listening from right now, and what time is it there? I'd love to know. The quiet hours have a way of turning ordinary thoughts into something slower, softer, more meaningful. And that's what we'll explore together tonight. Have you ever wondered why things fall? Why the oceans rise and shrink in rhythm? Or how the moon stays right where it is, not flying off into space and not crashing down on us? Tonight, we're going to drift through a story as old as the stars themselves. A sleepy story of gravity. Not just the gravity that pulls your cup to the floor when you knock it off the table, but the kind that holds. Galaxies together shapes the curve of planets and keeps your feet firmly on this strange spinning world. So lie back, let your breathing grow slow and easy, and together we'll follow gravity, the silent, invisible force that touches everything and never sleeps. Gravity has no face, no sound, no color, and yet it is the most faithful companion. Any of us will ever know a constant presence from the moment we are born to the moment we draw our last breath, and even then, long after we're gone, it continues to tug at what remains, from the crumbling edges of a mountain to the floating ash of an extinguished fire. Gravity is there, patient and tireless, holding everything together in silence. Long before you or I were born, before Earth had mountains or rain, before there were oceans or even the sun itself, gravity was already at work, not as a thing created, but as a quality. The universe simply had an invisible pull stitched into the very fabric of space and time. Like the grain of wood or the swirl of cream in coffee, a quiet curvature in the way everything moves. It's hard to picture something so universal and yet so invisible. If gravity had a sound, perhaps it would be the low hum of deep time, or the sigh of a planet breathing across centuries, but instead it speaks through motion, through closeness and collapse, through the way things fall and swirl and stay. On Earth, we often think of gravity as something that pulls down, the apple that drops from a branch, the pen that rolls off a desk, the feeling of weight in your bones when you lie down at the end of the day. But gravity doesn't only pull downward, because in truth there is no universal down, no up either, only toward, always toward. A reaching that everything in the universe performs constantly and without question. The reason you're not floating right now, drifting weightlessly like an astronaut, is because the Earth itself, vast, old, and turning beneath your feet, is reaching toward you with gravity, and you, by simply existing, are reaching back. It's a strange kind of relationship, silent and one-sided in many ways, and yet it is entirely mutual. Your body doesn't resist this pull. It accepts, it grows around it, adapts to it, so completely that you don't notice it at all, unless something disturbs it, like when you trip or jump or fall. And even then, gravity isn't cruel. It isn't punishment when you fall. It's simply the world reminding you that it never stopped holding you, even for a second. Now imagine, if you will, the Earth itself. A massive rock hurtling through space at thousands of miles per hour, spinning and orbiting and flying without ever crashing into anything. And you might wonder how it all stays in order, how it doesn't just fly apart like marbles flung from a sling. And the answer, once again, is gravity. Not just Earth's gravity, but the Sun's, which is far larger and older, and holds Earth and all the other planets in a great slow waltz that has lasted for billions of years. The Sun is so massive that its gravity bends space around it like a spoon in soft honey. And all the planets follow those curves not because they are told to, but because they must. Because gravity is not a command, but a condition. The shape of how things move when they are allowed to move freely. A dance choreographed by nothing and no one, and yet somehow always in time. What's truly astonishing is that gravity is not limited to stars or planets. Everything that has mass has gravity. Even you, even me, even the quiet chair beneath you or the phone in your hand. And though the gravity of small things is almost impossible to detect, it is there, weak and whispering but real. Right now your body is pulling on the pillow beneath your head, and the pillow is pulling back. Not enough to feel, not enough to measure, without precise instruments, but enough that if you removed everything else in the universe and left just you and the pillow floating in the dark, eventually you would drift together and touch. It's this quality, this omnipresence of gravity, that makes it so mysterious and so comforting. Because no matter how far apart two things are, no matter how lost or forgotten, gravity never lets them go completely, never severs the link, no matter how faint. But there's something else, something almost poetic. Gravity doesn't just pull things closer, it also gives things shape. Without gravity, Earth wouldn't be round, stars wouldn't be spheres, and planets would never have formed at all. In the early days of the universe, when it was still wild and hot and chaotic, tiny bits of matter began to clump together, not by accident, not by choice, but because gravity wanted them closer. Dust became pebbles, pebbles became rocks, rocks grew into planetesimals, and then full planets shaped and held by gravity's endless patient hands. And when those planets cooled and oceans formed, gravity continued to act, guiding rivers downhill, pulling tides in and out in rhythm with the moon, sculpting landscapes not in minutes or days, but in epochs, carving canyons, raising mountains, pressing layers of earth into stone. It even shapes time in a way that seems almost magical. Einstein showed us that gravity bends not just space, but time itself, so that in stronger gravity time runs a little slower, just a little, but enough to matter. The clock in your GPS satellite ticks a tiny bit differently from the one on your kitchen wall. And unless we adjust for that, your map wouldn't work, your directions would drift, and you'd be lost, all because gravity has the power to stretch and compress the very fabric of reality. When you lie very still, late at night, and everything is quiet, gravity is still there, still holding you close to this earth, this moment, this breath. And in some ways, that's what makes sleep possible too. Not just the pull of tiredness, but the safety of knowing you won't float away, that the world will still be beneath you when you wake. And maybe, just maybe, gravity is the reason dreams feel so grounded, even when they're filled with impossible things. Because even in sleep, the earth does not let you go, and neither do the stars. By the time the first light of morning reached the observatories of 1859, something extraordinary had already begun. On September 1st of that year, a man named Richard Carrington stood in his quiet observatory near London. He was a respected amateur astronomer, devoted to studying sunspots, the curious dark blemishes that dotted the sun's surface. Carrington's observations were methodical, careful, and routine until that day. At precisely 11:18 in the morning, he saw something no one had ever documented before. Two brilliant flashes of white light erupted from a cluster of sunspots. These flares burned with such intensity that Carrington, looking through his telescope's projection, stepped back in astonishment. They lasted less than 5 minutes, but what followed would become one of the most powerful natural events ever recorded in human history. At the time, Carrington didn't fully understand what he had just witnessed. The terminology for a solar flare didn't yet exist. But he recorded everything meticulously in his journal, unaware that he had just observed the beginning of what would become known as the Carrington event. The strongest solar storm to ever directly strike Earth. Within hours of the flare, a wave of charged solar particles raced toward Earth at unprecedented speeds. Normally, a solar storm might take 2 to 3 days to arrive. But this one, accelerated by an earlier ejection, reached the planet in just 17.6 hours. When it hit, the atmosphere responded with a display so breathtaking and so terrifying that entire towns gathered outside in the night, wondering if the world was ending. Auroras, those beautiful ribbons of colored light that usually dance in the polar skies, suddenly erupted over the Caribbean. In Rome, in Japan, in Havana. In the American South, people woke, thinking dawn had arrived at midnight. Skywatchers in Boston and New York could read newspapers by the light alone. And in the Western Territories, miners began preparing breakfast hours before sunrise, confused by the eerie illumination. But while the auroras were stunning, what came next changed everything. The electrical systems of the day rudimentary telegraph networks began to spark, fail, and in some cases, ignite fires. Telegraph operators reported being shocked through their equipment even when batteries had been disconnected. In some places, messages continued to transmit despite complete disconnection from power. Lines hummed with an invisible energy, fed not by man-made currents, but by the earth itself. In Montreal, lines overloaded and set fire to the local telegraph station. Operators watched in awe and confusion as metal keys grew hot to the touch and sheets of paper blackened from electrical discharge. And all across the continent, the same reports echoed. Systems shorted out, wires glowed, and the night sky burned like liquid fire. The source of this invisible catastrophe was something few understood, and even fewer could explain. In the decades since, we've come to understand solar storms as the result of coronal mass ejections, massive bursts of plasma and magnetic fields from the sun's atmosphere. But in 1859, this was unthinkable. The sun was regarded as constant, reliable, and benign. The idea that it could violently disrupt life on Earth, much less ignite fires in telegraph stations, was almost impossible to accept. And yet, Carrington's drawings, paired with the atmospheric effects observed around the world, left little doubt. The Earth had been struck by something vast and powerful, and no one knew if or when it would happen again. In the quiet that followed, as the auroras faded and telegraph networks were repaired, a strange unease settled over the scientific community. Carrington himself was deeply unsettled. Though he would go on to receive recognition for his discovery, the experience haunted him for the rest of his life. He never witnessed another solar flare, and despite his efforts, he never quite understood the full magnitude of what he had seen. His career waned, his health declined, and he died alone, convinced that the sky still held secrets that mankind was not ready to face. But his name lived on, not just in astronomy textbooks or observatory plaques, but in whispers among space weather researchers who study the sun's darker moods. The Carrington event became a symbol, a warning from history that even the comet star can awaken without notice. Today, modern scientists estimate that the Carrington solar storm released energy equivalent to 10 billion atomic bombs. Its blast reached out from the sun with a power we still struggle to quantify. If such an event occurred in our time, it wouldn't just disrupt telegraphs, would overwhelm satellites, destroy power grids, and crash communication systems that hold the fabric of modern life together. In the age of AI, GPS, and global financial networks, a Carrington-class storm could cause trillions of dollars in damage within hours, leading to cascading failures of transport, finance, defense, and medical infrastructure. This isn't a hypothetical. NASA, NOAA, and other agencies now monitor the sun daily, watching for the telltale signs that another Carrington may be on its way. Yet the sun remains both unpredictable and largely misunderstood. Despite all our technology, we cannot stop it. We can only prepare and wait. Carrington's ghost lingers in every solar observatory, in every warning flare watched from a satellite in orbit, and in every late-night conversation between scientists who wonder, what would happen if the sky cracked open again? When will it happen? And what would be left of our world when the storm finally passes? Long after Richard Carrington's notes faded into yellowed archives, a new generation of scientists began studying the sun, not just as a glowing disk in the sky, but as a living, breathing entity. They watched as sunspots rotated into view, grew like slow hurricanes, and vanished with a final burst of energy. They observed the cycles, strange rhythms that pulsed across the surface of the star, repeating every 11 years or so with a kind of cosmic heartbeat no one fully understood. This became known as the solar cycle, a pattern of solar activity that begins with a quiet sun, gradually builds in turbulence, and reaches a peak known as solar maximum, when flares, storms, and eruptions become more common and more dangerous. It was during these peaks that Earth seemed most vulnerable. The sun, usually so calm and dependable, would erupt with astonishing violence, sending loops of plasma larger than entire planets arcing into space. If these loops, called coronal mass ejections, were directed toward Earth, they could crash into the magnetic field that surrounds our planet and ripple through the atmosphere like waves through still water. Scientists began calling these interactions geomagnetic storms, and they found that some were harmless and others were catastrophic. The solar cycle operates like a silent gear behind time itself, ticking away above our heads. Every 11 years, it resets, beginning anew. But no two cycles are exactly the same. Some are mild, barely ruffling the atmosphere. Others are aggressive, sending warning pulses through the Earth's magnetic field that linger for days. Satellites lose orientation. Astronauts aboard the International Space Station are advised to take shelter. Airlines reroute flights to avoid polar exposure, and radio signals travel strange paths across the planet. We don't often feel it, but the sun is always whispering to us, sometimes warmly, sometimes with warning. As the years passed, we built machines to listen to those whispers more carefully. Instruments aboard satellites like SOHO, Stereo, and Parker Solar Probe now monitor solar winds and magnetic shifts in real time. They allow us to see what Carrington never could: the early signatures of a flare before it erupts, the pulse of a storm long before it reaches Earth. But even with all our technology, we are still just observers. We cannot stop a flare. We cannot deflect a coronal mass ejection. All we can do is watch, and prepare. And preparation has become more urgent than ever. In 1989, a moderate solar storm knocked out the entire power grid in Quebec, Canada. In the span of 90 seconds, the lights went dark for 6 million people. Transformers failed, lines overloaded, and entire cities found themselves helpless in the cold of March. What was shocking was not the intensity of the storm, but how unprepared we were for it. The sun had not even unleashed its full power. 'Twas a glimpse, a quiet knock at the door compared to the hammer of the Carrington event. This realization led to a new branch of science: space weather forecasting. Teams of researchers now issue alerts much like meteorologists do, predicting solar storms, auroras, and potential disruptions to GPS systems and power grids. Governments have begun to take the threat more seriously. Emergency protocols exist for major utilities. Airlines monitor solar radiation daily, and financial institutions whose systems rely on split-second timing now consider solar storms a real and growing threat. But despite these efforts, something troubling remains: a sense that we are not ready. Not really. True Carrington-level storm, even with hours of warning, would overwhelm modern systems faster than they could shut down. Transformers in the United States, many decades old and difficult to replace, could fail in large numbers. Communications satellites could be fried beyond repair. The global economy, so intricately connected through digital threads, could fray or snap entirely. And all of it could begin with a single flash of light, just like the one Carrington saw over 160 years ago. The storm would come in silence. There would be no sirens, no winds howling through the streets. Only the glow in the sky and the strange flickering of screens, and the realization that something vast had just swept across the Earth. Scientists have models for this now. They've run simulations of what a modern-day Carrington event would do. The results are sobering. A storm of that magnitude could cause damage exceeding $2 trillion in the first year alone. Power grids would collapse. Banks would freeze. Water treatment plants and emergency services would falter. Air traffic would halt. In the worst-case scenarios, entire cities could be without power for weeks, even months. And what's perhaps most unsettling is how few people even know this is possible. We go about our days, glancing at the sun as if it were only a source of warmth or light. We forget that it's also a storm god in quiet slumber, capable of awakening with a fury we cannot stop. Our ancestors worshipped the sun, feared it, watched its moods like oracles reading fire. In a strange way, they understood something we've almost forgotten. The sun gives life, but it also holds the power to take it away, not by burning us directly, but by unraveling the delicate systems we depend on. The more connected we've become, the more fragile we've made ourselves. A farmer 200 years ago might not have even noticed a solar storm. But a doctor in a modern hospital, a pilot in midair, a stock trader watching markets ripple across continents, they would feel the impact in seconds. Our civilization is built on wires and code, satellites and signals, data and light. And all of those things, every last one begins to flicker when the sky begins to stir. But there is also something strangely beautiful about this threat. The sun's anger is not malicious. It is not punishment. It is simply nature, vast and wild and indifferent. A reminder that we are part of a system much older and larger than ourselves. That our stories are written in the light of a star that burns quietly most days, and sometimes sings in fire. As you rest tonight, think of the stars above you, not as distant specks, but as restless giants. And think of our sun, steady, kind, and sleeping, but never without the potential to awaken. There is peace in knowing. There is wisdom in watching. And there is power in remembering that even the quietest sky can crack open without warning. As we drift further into the delicate dance between Earth and its star, we begin to understand that our relationship with the sun is not just physical, not just energetic, but deeply woven into the very way we think, the way we feel safe, the way we imagine permanence. And yet, the truth is, nothing about the sun is permanent. It is a roiling, ever-shifting ocean of fire and force, a star constantly at war with itself, balanced for now, but destined, one day, to change. But it is not just the future that deserves our attention. There are stories buried in more recent decade stories, not as dramatic as the Carrington event, but unsettling in their own quiet way. One such event took place in 2003, during what scientists now call the Halloween storms. On October 28th and again on the 29th, the sun unleashed a pair of powerful solar flares, classified as X-classed, the most intense kind. These flares were followed by massive coronal mass ejections that raced toward Earth at speeds exceeding 2,000 kilometers per second. When they arrived, the planet trembled. Satellites blinked out. GPS signals faltered. Radio communication went dark across entire regions. In Sweden, a major transformer failed, cutting power to tens of thousands. Airline flights were rerouted. Radiation levels on high-latitude routes spiked, and auroras blazed so intensely they were visible as far south as Texas and Italy. These weren't gentle greens and soft purples, either. These were curtains of red and gold, sweeping across the sky like fire caught in the wind. And yet, most people didn't notice. They slept through it, unaware that the systems around them had groaned under the weight of a star's outburst. It was a warning, not loud but clear, that the sun still watches us, and sometimes, it speaks. Then, in July of 2012, something even more astonishing happened. A coronal mass ejection, at least as powerful as the one that caused the Carrington event, exploded from the surface of the sun. But this time, Earth was lucky. The blast missed us by just a few days if it had erupted while the sun was facing our planet. The consequences could have been catastrophic. Scientists at NASA reviewed the data with awe. One of them said, if it had hit, we'd still be picking up the pieces. That storm, by all accounts, could have caused a global blackout. GPS, internet, power grids, satellites, even backup systems overwhelmed in minutes. This near miss raised uncomfortable questions. What if? What if it happens next year, or tomorrow, or in the middle of the night while the world sleeps, unaware that the sky is cracking open above them? And what if we only have a few hours to prepare, to disconnect transformers, to ground airplanes, to shut down satellites, to unplug ourselves from the very systems we depend on? Many scientists agree we need a planetary warning system, a solar early warning network as robust and respected as those we have for hurricanes or earthquakes. But funding is limited, and interest tends to rise and fall with each solar cycle. When the sun is quiet, we forget. We always forget. But the sun does not. It continues to turn, to breathe, to storm in silence. Its energy feeds our crops, powers our weather, charges our cells. And yet, at its extremes, it can erase entire networks, silence continents, and remind us of just how temporary all of this really is. We sit beneath the illusion of stability, and the sky watches us, ancient and unknowable. In labs around the world, researchers now build simulations of solar weather. They model the twists of magnetic fields, the waves of plasma, the solar winds. They create digital suns and watch how they erupt, trying to anticipate how the real one might behave. They do this not to tame the sun, but to understand its moods, its habits, its deeper story. One day, we may be able to predict its tempers with accuracy. But for now, our best hope lies in listening carefully, staying alert and not dismissing the sun's voice when it rises from silence into fury. And yet, even now, there's something poetic in the threat. The most dangerous storms don't rage on the ground. They bloom in the sky, in silence, invisible until it's too late. The force that warms your face in the morning, that casts golden shadows on your walls at dusk, is the same force that, when provoked, could pull the world into darkness. But it's not about fear. It never has been. Fear belongs to myths and warnings. What we need is reverence, a quiet respect for the system that cradles us in its light and humbles us with its reach. It reminds us that we are guests in a cosmic ecosystem so vast, so beautifully complex, that even a heartbeat of the sun can echo through every circuit on Earth. So tonight, as your eyes grow heavy and the world softens around you, imagine the sun as something not to fear, but to understand. A storyteller in the sky, writing its verses in light and plasma, waiting for us to learn the rhythm of its songs. You are part of that story now, and the more you learn, the more you listen, the safer we all become. Close your eyes gently and picture it. A field of fire 93 million miles away, wrapped in loops of dancing energy, watching us as it has for billions of years, still burning, still turning, still dreaming. High above our heads, beyond the clouds, beyond the reach of weather and birds and even the tallest plains, lies a region of space most of us never think about. A place neither truly Earth nor fully space. A boundary where the planet begins to fade into the void, and where human invention clings to invisible threads. It's here that satellites orbit silently, thousands of them, each a small metal eye staring down at the Earth or peering deep into the cosmos. They carry our voices, our photos, our maps, our memories. They are the scaffolding of modern civilization, spinning endlessly in perfect coordination without applause or attention. But these silent machines have enemies. Not bullets or bombs, but energy. Invisible surges of radiation, waves of charged particles, currents of solar wind. To a satellite, the sun is not just a distant star. It is a constant threat, a source of life, and the possibility of instant death. When a solar storm reaches Earth's magnetosphere, it doesn't just color the skies with auroras. It attacks these machines with particles moving at the speed of fury. The storms cause electrical charging on the surface of satellites, which leads to discharges, mini lightning strikes across their panels. If these charges grow too intense, they can fry the systems instantly, killing the satellite in a heartbeat. Imagine one small surge, one barely visible spike in energy, silently ending a billion-dollar mission, and suddenly GPS fails. Weather forecasts become unreliable, television signals flicker, global communications ... interrupted. In 1994, 2 Canadian telecommunication satellites were disabled by a solar storm, knocking out phone service for over 6 million people. In 2003, during the Halloween storms, more than a dozen satellites experienced critical failures. One Japanese satellite, built for deep space imaging, simply went dark and never came back. Billions of dollars lost, data lost, and more importantly, the reminder that we rely on systems held together by invisible, fragile threads. But satellites aren't the only things at risk. Closer to the ground, a vast network of cables and transformers spreads beneath our feet, under oceans and deserts and mountains. The power grid, humanity's most essential invention, and it too is vulnerable. When a strong solar storm arrives, it distorts Earth's magnetic field. This distortion induces electrical currents in long conductive lines, like power lines and pipelines. These are called geomagnetically induced currents. And they can overload transformers, damage circuit breakers, and ignite fires. In March 1989, a solar storm took down Quebec's entire power grid in just 90 seconds. Millions of people were suddenly in the dark, heatless in the freezing cold, with no idea what had happened. That storm wasn't even close to the strength of the Carrington event. Imagine now a similar storm in our time. Not 1989, but today, with millions more transformers, hundreds more satellites, and systems built with just-in-time efficiency. In our pursuit of speed, we have forgotten redundancy. There is no room for delay, no cushion, no backups for many systems. One good solar storm and modern civilization pauses. The scary part isn't just the blackout, it's what happens after. Hospitals switch to generators, but only for a few hours. Water treatment facilities fail. Food refrigeration begins to break down. Traffic lights, internet access, credit card systems all halted. Banks close. Emergency services struggle to communicate. It's not just an inconvenience, it's a cascading effect, and the deeper it goes, the harder it is to restart. And here's the twist. We probably won't get much warning. The sun doesn't text ahead. When a coronal mass ejection is launched in our direction, we may have a window of 12 to 24 hours, at best. That's if we're watching carefully. That's if we notice it at all. Right now, our best tool for early detection is the Solar and Heliospheric Observatory, a joint NASA and ESA satellite that watches the sun constantly. But it too could be disabled by the very event it's meant to detect. If it goes offline during a storm, we may lose our only eyes in the sky. And without eyes, we are blind. Some governments and agencies are working to prepare, establishing protocols, reinforcing grids, developing solar weather models. But many experts believe it's not enough. Solar weather remains a second-tier concern in most national threat assessments. It doesn't inspire fear the way earthquakes, pandemics, or wars do. Maybe because it's invisible. Maybe because it doesn't feel real. But to the engineers in control rooms, the scientists at solar observatories, and the historians who've studied the Carrington event, it is very real. They whisper warnings at conferences, write papers with titles like The Vulnerability of Modern Infrastructure to Solar Storms, and hope someone listens before the sky cracks open again. There is a strange comfort in knowing the threat comes not from hatred or human malice, but from something ancient, natural, and indifferent. The sun doesn't target us. It simply exists. And sometimes it sighs. And that sigh, that elegant storm of charged particles and magnetic loops and radiant pressure, carries with it the power to make us remember how small we are, how connected we become, and how easily the thread of modern life can fray. Yet, even with all these vulnerabilities, we continue to rely on light. It's the poetry of civilization. We turn on lamps without thinking. We tap into the web without questioning the invisible flow behind it. We send our voices across oceans through satellites that whisper in the void. The sun, for all its fury, has made this possible. And still, one day, it might take it all back. Just for a moment. Just to remind us. There's something humbling in that. Something worth listening to. As you close your eyes tonight, breathing calmly, sinking into the stillness of this moment. Remember the quiet electric heartbeat beneath everything. The pulse of signals, currents, and fields. They are not permanent. They are not promised. They are the invisible gifts of a planet embraced by a star. And someday, that star may remind us who's really in charge. When people think of solar storms, they imagine fire. Bursts of light, blazing energy, solar flares leaping across the face of the sun like ribbons of flame. But for those who understand what comes next, who know what happens when all that energy meets the fragile systems we've built, the more accurate metaphor might be ice, stillness, silence, a world stopped cold. In the event of a major solar storm, something on the scale of the Carrington event or stronger, the power might go out not just for hours, but for days, weeks, even months, because this time it's not a single wire downed by wind. It's an entire grid shorted out by space itself. And that's where the freezing begins. Let's imagine it together. You're lying in bed. It's the middle of the night. Outside, the wind is calm. Maybe it's winter, maybe it's summer. Either way, your world is quiet until the hum disappears. The refrigerator clicks off. The thermostat stops glowing. The gentle whoosh of heat or air conditioning vanishes. You wake up to a strange silence. You check your phone. No service, no Wi-Fi. No signal at all. In your city, traffic lights are dark. Elevators stuck. A Ms. lifeless. And in the distance, sirens begin to echo. Not just one or two, but many. Because this isn't local. This is everywhere. Hospitals run to their emergency reserves. Some last a few hours, some a little longer. But generators depend on fuel, and fuel depends on logistics. And logistics depend on ... electricity. Soon, the real problems begin. Supermarkets close. Not because food is gone, but because refrigeration is, and security and payment systems. Within days, spoilage sets in. Within a week, it's not just convenience that's gone. It's food itself. People begin to ration what they have. Batteries run down. Radios go silent. Gas pumps stop working. Credit cards become useless plastic. And without power, water becomes the next crisis. Municipal pumps that carry water to apartments and homes are offline. Toilets stop flushing. Faucets run dry. And in a city, when water disappears, so does hygiene. So does health. Disease spreads faster in the dark. Fear, even faster. Now imagine this isn't a disaster zone. It's your home, your neighborhood, your city. A solar storm doesn't hit one place. It hits everywhere at once. It moves at a speed we can barely comprehend. And it doesn't care how rich or prepared a place seems. The storm touches all, north to south, east to west. The pulse enters through the sky and seeps into the earth. For decades, emergency planners have quietly modeled scenarios like this. In classified briefings and academic papers, they explore how long cities could function without power. How long before backup fails? How long before order breaks down? The numbers aren't reassuring. The thing is, solar storms don't destroy in the dramatic way we reused to seeing in disaster movies. There's no explosion, no fireball, no dramatic wind or shaking ground. It's worse in some ways because everything just stops. The lights stay off. The hum never returns. And people begin to realize that every piece of their normal life depends on something they never thought about. The quiet, uncelebrated miracle of electricity. That's when the freezing happens. Not just the temperature dropping in homes without heat, but the cultural freeze, the economic freeze, the psychological freeze. People waiting, uncertain, holding their breath in the dark, wondering how long it will last. You might think people would panic right away. But at first, they don't. The first day, they wait. The second day, they hope. By day 3, the questions grow louder. Where are the updates? What's happening? But there are no answers. Because the satellites are down. The communication networks are fried. The people who know what happened, astronomers, engineers, solar physicists, can't tell anyone. Their data systems are dark too. Some communities begin to come together. Neighbors sharing food. Old generators brought out from garages. People rediscovering candles, handwritten notes, and wood-burning stoves. In rural areas, people fare slightly better. They're used to self-sufficiency. But in the cities, where everything depends on power, transport, water, security, time is running out. And here's the quiet terror no one talks about. The grid wasn't built to restart easily. Transformers that burn out don't get replaced with the flick of a switch. Many are custom-built. Some take months to manufacture. And if several dozen go down at once, or hundreds, there aren't enough replacements on Earth to rebuild the system quickly. This isn't hypothetical. A 2012 NASA-funded study warned that a Carrington-level storm today could cause between $1 and $2 trillion in damages within the first year. It could take 4 to 10 years to fully recover. Not because the damage is invisible, but because the system is too vast, too interconnected, too fragile. And all of it hinges on one truth. We never expected to fall backwards. We built up, taller, faster, smarter, but never built a way back down. No off-ramp to simplicity. No plan for silence. In a post-solar storm world, we might find ourselves looking at the stars with new eyes. No longer as a source of wonder, but as a reminder of risk. The same sun that feeds our crops and warms our skin has always held the power to shake our illusions of control. It happened in 1859. It almost happened in 2012. And in the ticking silence of our electric age, will happen again. But maybe, just maybe, there's a gift in this imagining. It's a chance to prepare, to build better, to listen to the scientists who warn, not in panic, but in gentle persistence, to make systems that bend, not break, to teach children that the stars are not just distant, but intimate, that the sky above shapes the world below. And as we drift tonight, warm beneath our blankets, surrounded by devices that hum and glow and blink, maybe we pause for a moment to acknowledge the stillness beneath it all, the silence waiting on the other side of the switch, the breath between signals, the world we hope never comes, and the knowledge we must carry, just in case. Because one day, maybe sooner than we think, we might wake to a world that has stopped. And in that silence, in that pause, the only thing that moves will be the sky. Long before the lights go out, before the grid groans under the weight of cascading failure, before cities descend into silence and stillness, the very first casualties of a solar storm aren't on the ground at all. They re above us, circling in silence, suspended in the void on threads of mathematics and metal. These are our satellites, hundreds of them, maybe thousands. Each one fragile in its own way, each one floating in orbit. Invisible to the naked eye, but crucial to almost every part of modern life, they guide our planes. They process our bank transfers. They help farmers know when to plant, truckers know where to drive, doctors know where to send emergency data. They give us weather reports, stock prices, GPS directions, international calls, and even the timing of the world's financial transactions. Because time itself, that universal heartbeat of modern life is now kept in space. And this is where the solar storm strikes first. When the sun sends out a coronal mass ejection, ACME, it hurls billions of tons of charged particles toward Earth. And when those particles arrive, they don't just hit the atmosphere. They surge into the planet's magnetic field, warping it, twisting it, stretching it like a rubber band that suddenly snaps. And the energy released by that motion moves fast, creating electric currents and electromagnetic pulses that ripple through the upper atmosphere. Satellites orbit in that invisible sea, and while their outer shells are hardened, many of their components are not designed for this level of radiation. And so things begin to fail. First come the communication glitches, dropped signals, scrambled transmissions. A satellite that suddenly can't stay in sync with the others. GPS systems begin to drift. Planes and ships notice their locations are a little off. And in navigation, a little is sometimes all it takes for disaster. Then come the power anomalies, batteries that begin to overheat, onboard computers that suddenly reboot or shut down entirely, instruments that give false readings or none at all. And in the worst cases, entire satellites stop responding, spinning silently through space like fallen leaves on a windless lake. And here's where it gets worse. Solar storms do something else, something unexpected, something most people don't realize. They make the atmosphere grow. High up above the planet, where the air is thin but still present, solar storms dump so much energy into the Earth's upper atmosphere that it expands outward like a balloon under heat. And suddenly, satellites that used to glide through near-empty space are encountering more drag, more resistance, more friction, and for those in low Earth orbit, it means they begin to slow down. When they slow down, they fall bit by bit. Their orbits decay, their paths begin to sink. And unless ground control can correct them, and remember, that depends on functioning systems on Earth, they begin to tumble toward the atmosphere. Not in fiery spectacle like in movies, but in long, drawn-out spirals that eventually end in heat and vapor and ash. During the Carrington event of 1859, there were no satellites to fall, no GPS to lose, no orbiting cameras to blink out. But if the same storm happened today, our orbital infrastructure, our invisible nervous system would be at immediate and serious risk. In 2003, during a solar event known as the Halloween storms, 47 satellites experienced some form of failure or anomaly. Several were permanently damaged, and that was from a storm much weaker than the Carrington burst today. We have thousands more satellites than we did then, and they serve not just governments, but hospitals, banks, delivery services, emergency responders. They are, in a very real sense, the digital bloodstream of modern civilization. And when they go down, we don't just lose entertainment or convenience. We lose timing signals that coordinate the power grid. We lose synchronization that underpins global finance. We lose the silent coordination that keeps planes from colliding and ambulances from getting lost. And perhaps most haunting of all, we lose eyes. Eyes that watch the weather, track hurricanes, monitor wildfires, scan the oceans for ships in distress, and warn us about the next solar storm itself. Yes, you heard that right. If a solar storm is strong enough, it could knock out the very instruments that warn us about solar storms, leaving us blind at the moment we need sight most. This has happened before, not a full shutdown, but disruptions that temporarily blinded our solar observatories, and the idea of a cascading storm, where one CME disables part of our detection network, and a second, stronger one follows, unseen and unprepared for, is a real and frightening possibility. Because the sun doesn't send warnings, it sends waves, and sometimes those waves come in clusters. In 2003, 3 major CMEs arrived in succession, and the second was so powerful that it overtook the first. A kind of collision in space that amplified the intensity of impact on Earth. We got lucky, but luck is not a strategy. So what do? Scientists and engineers have proposed ideas. Better shielding for satellites, more resilient onboard systems, improved space weather forecasting, even networks of satellites designed to back each other up. But these systems are expensive, and space is political, and the funding rarely matches the urgency. And so we continue to float in this uncertain place, surrounded by machines that make life possible, yet threatened by the very star that gives us life. There's a strange poetry in that the giver of warmth could also bring the cold, that the brightest light in our sky could plunge us into darkness, that the sun, in its silence, holds the power to rewrite the story of civilization, not with fire, but with a whisper of plasma across magnetic lines we cannot see. And as you lie back tonight, maybe under a blanket, maybe in the quiet dark of your room, the devices around you still humming with life, just know that above you, circling silently, the satellites are still holding. For now, but they are the first to fall, and when they do, begins. After the satellites begin to fail, after the delicate threads that link our world from space start to fray and snap one by one, the next great vulnerability lies. Not above us, but all around us, embedded beneath our cities, strung between metal towers, humming across open fields and woven through neighborhoods like veins under skin. This is the power grid, vast and invisible, essential and fragile. The system that keeps the lights on, the hospitals running, the water flowing, and the world breathing in its modern form. And this is where a solar storm becomes not just an astronomical event, but a civilization-altering force when the charged particles from a coronal mass ejection arrive at Earth. They don't just shimmer harmlessly in the sky as auroras, though the auroras will come bright and dancing. Sometimes seen as far south as Cuba or Rome. Beautiful, yes, but also a warning, because those dancing lights are a sign that invisible energy is racing through the planet's magnetic field, disturbing it, bending it, injecting it with force far beyond what it was built to contain. And as that magnetic field distorts, something begins to happen. Underground currents begin to flow where they shouldn't. These are geomagnetically induced currents, or galaxies, electric surges that build up in the Earth itself and surge into anything long and metallic. And the power grid is full of such things. High voltage, transmission lines, grounding wires, transformer cores, all of them perfectly designed to absorb and conduct electricity, even when it wasn't meant to be there. And so the current flows in slowly at first, like a breath being held, and then sharply, like a gasp. Transformers, those massive humming beasts that sit at substations, are especially vulnerable, not just because of the sudden current, but because of how it flows, asymmetrical and sustained, slowly overheating their cores, creating magnetic flux that distorts their function, and in worst cases, it causes catastrophic failure. These aren't light bulbs you can replace. High voltage transformers are custom built, weighing hundreds of tons, sometimes taking months or years to manufacture. And many countries, even the most developed ones, don't keep enough spares on hand to replace more than a tiny fraction of their fleet in 1989. During a solar storm far smaller than the Carrington event, the entire province of Quebec lost power in just 92 seconds, not because a wire snapped or a line fell, but because a surge flowed invisibly through the ground and overloaded the system, knocking out power to millions of people, shutting down schools, hospitals, airports, and rail systems, and plunging the city into dark silence until emergency crews could restore power days later. That was one region, one storm, one warning. The next time, it could be many, because our grids are more connected now, not less. In North America, the eastern grid stretches from Canada to Florida, and from the Mississippi to the Atlantic, with interconnections that make it resilient in some ways and dangerously vulnerable in others. If a surge knocks out key nodes in that web, the failure can cascade like dominoes, falling like threads unraveling. Imagine it now. A surge enters the Earth in Maine or Minnesota, maybe silently, maybe with only a flicker of the lights, and before anyone can react, It's raced through substations, burned out transformers, tripped safety relays, overloaded lines across several states, and sent control centers into chaos as operators scramble to isolate the damage. But their communication lines are already struggling because the satellites above have failed, and so the darkness spreads. Power stations begin to trip offline, both to protect themselves and because their load suddenly has nowhere to go. And in a matter of minutes, entire cities go black. The water pumps stop first. Not because there's no water, it's because there's no power to pressurize the systems. Then go the sewage treatment plants, the traffic lights. The hospital's backup systems begin to whine under the strain. Grocery stores lose refrigeration, gas stations shut down, and phone towers go quiet. Modern life is built on an unspoken assumption. That power will always be there, but a storm from the sun could take it away. Not in theory, but in reality. Not in centuries, but in hours. And if you're thinking, surely there's a plan for this, you're right. There are protocols, models, simulations, even drills in some countries. Okay. And power utilities know about GICs and monitor space weather alerts. But the truth is, much of the infrastructure in place today wasn't designed for solar storms. And even with warnings, the magnitude of the damage would depend on where the storm hits, how fast and what angle it strikes the magnetosphere. A direct hit from a storm as large or larger than the Carrington event would be like trying to stop a tidal wave with sandbags. And here's a haunting fact. The 2012 solar superstorm, a Carrington-class CME, missed Earth by just 9 days had our planet been in a slightly different position in its orbit. We would have taken a direct hit. NASA's Stereo A spacecraft, which was monitoring the storm, recorded that it was as powerful, as fast, and as magnetically dangerous as the one in 1859, and had it hit. Scientists estimate that power outages would have been widespread and long-lasting, possibly taking months to fully repair. With economic losses in the trillions and impacts to everything from food distribution to water sanitation to medicine refrigeration, and if it had hit at night, most of us would have gone to bed thinking everything was normal, and woken up to a world in darkness. So why don't we hear more about this? Why isn't it on the news, in our schools, part of our public awareness? Maybe because it's too big to think about, or because the sun, in all its brightness and warmth, seems more friend than foe, or maybe because we trust the grid without understanding it, because we believe deep down that the wires will hum forever. But wires are not magic. They are metal and magnets and timing and trust, and the sun does not negotiate. It does not send warnings with compassion or malice. It simply releases what it must, and we, on our small blue planet, with all our wires and lights and dreams, must decide what to do with that knowledge tonight as you lie quietly, maybe with the gentle hum of a fan, the glow of a bedside lamp, the distant sound of power running smoothly through the walls. Just know that all of it, every watt, every circuit, flows through systems sensitive to forces 93 million miles away. And when the sky cracks open, it will not knock. It will arrive suddenly and without apology through the ground into the grid and into every corner of the world we've built on electricity. What happens next is not science fiction, it's science fact, waiting for time and chance. But for now, the lights are still on and you are safe. Sleep well for now. Imagine waking up and finding the world unchanged in appearance. Your walls still standing, your bed still warm, the sun rising outside your window in its familiar arc. And yet, something fundamental has shifted beneath the surface. Something you can't see or touch, but can feel. A silence where there should be a hum. A stillness where there should be motion. The power is gone, not flickering, not delayed, not resting in standby, but entirely absent. As though the very concept of electricity had been erased overnight. And this isn't a localized outage or a flick of a breaker. This is the world unplugged. Civilization suddenly quiet in the way a forest is quiet after thunder has passed. There is no running water in your faucet because the pumps are silent. Number cell phone reception because the towers are dead. No heating unless it's wood. No cooling unless it's wind. Refrigerators sit idle. Clocks stop mid-tick. Elevators freeze between floors. Credit cards become pieces of plastic without the networks to support them and the convenience of the modern world. The ease, the automation, the comfort vanishes not with an explosion, but with a whisper. For the first few hours, many people wouldn't realize what had happened. They'd wait patiently, thinking it's temporary. Perhaps a storm knocked out a transformer or a blown fuse needs replacing. They'd check their phones and wonder why there's no signal, why the Wi-Fi isn't working. They'd open the fridge, still cold from the night, and believe everything will be back soon. But as the day unfolds and nothing returns, as the sun arcs higher and the streets remain oddly quiet, no traffic lights blinking, no mechanical sounds from behind storefront doors, reality begins to settle like dust on an untouched windowsill. The realization is not dramatic, creeping, slow, unsettling, and it brings with it a deeper question. How much of our lives depend on something we cannot see because electricity is invisible? You don't see it when you plug in a lamp or open your laptop. You trust that it's there, that when you flip a switch, something will happen. And it always has, for your entire life, until now. And in its absence, a strange, ancestral feeling begins to stir in the background. A memory, not yours, but older, carried through generations, about how to survive without it. But survival is not instinctive in cities. It's designed around supply chains, thermostats, fuel deliveries, GPS signals. Digital transactions remove those systems, and even the basics of life become tangled in uncertainty. Grocery stores can't restock, not just because of supply trucks failing to arrive, but because those trucks rely on electronic logistics systems, on refueling stations that require power, on drivers who may not be reachable or paid without digital networks. And even if they arrived, the cash registers are useless. The refrigeration units have already failed, and within 24 hours, perishable food begins to spoil, and the water, the most essential element of life, begins to run dry without electrical pumps. The reservoirs can't deliver pressure. The taps run empty or slow to a trickle. And in high-rise apartments, the water doesn't rise at all. In rural areas, well pumps go still, and those with manual backup systems begin to realize they are no longer quaint. They are essential. Hospitals rely on backup generators, but even those have limits. They run on fuel, and fuel distribution is one of the first casualties in a grid collapse. Once the diesel runs low, triage decisions begin. Machines go silent. Surgeries are delayed or abandoned. Neonatal units must make impossible decisions. And all of this unfolds not in a single disaster zone, but across entire regions, even entire continents. If the solar storm was strong enough and hit the right way, communication vanishes. Next, radio towers stop transmitting. Fiber optic lines require repeaters powered by grid energy. Internet traffic plummets. Satellites may already be compromised from the storm's radiation. And even shortwave radio begins to fail under the noise of solar interference. We are not used to silence anymore. We are not used to not knowing. People begin walking to find information. They crowd around battery-powered radios or cars where news, if any, might still come through. They speak in anxious tones about the blackout, about government response, about the hope that someone, somewhere is in control. But the longer the silence lasts, the more those hopes begin to dim. And in the absence of news, rumors flourish. People begin to guess, to imagine, to fear. Is it an attack? Is it global? Is it permanent? The uncertainty becomes its own form of crisis. But there are deeper shifts happening. To beneath the panic, beneath the adjustment, something strange begins to reawaken. People start to gather again. Not on screens, but in person. Neighbors talk over fences. Candles glow behind curtains. Food is shared in backyards because it will spoil otherwise. And conversations that would have never occurred before now take place under open skies with nothing else to do but speak and listen. Children, unaccustomed to silence and boredom, begin to play with sticks and stones and voices. They adapt faster than the adults. They chase fireflies and draw in the dirt, and for a brief moment, something lost begins to return. The stars become visible again. Without the glow of 1,000 city lights, the Milky Way stretches across the sky like a whispered memory. And people who haven't looked up in years begin to tilt their heads and wonder what else they've forgotten. And yet, wonder cannot erase hardship within days. Those without access to water begin to suffer. Those dependent on machines for life support. Those needing refrigeration for medicine. The elderly who cannot regulate body temperature, all begin to decline. And aid cannot arrive easily without power. Coordination falters, logistics freeze. National response becomes a patchwork of local efforts trying to operate with paper maps and word-of-mouth instructions. This is not a dystopia of fire and ash. It is a quiet, creeping unraveling. And in that unraveling, we see both fragility and resilience. The solar storm that caused it may have passed in hours, but its impact could stretch for weeks, months, even years, depending on the damage. And recovery would not be linear. Some regions may restore power faster. Some transformers might never be rebuilt, and certain rural areas could become isolated for good. And yet, people would endure. They always have. But they would remember that everything they relied on, the hum of the fridge, the glow of a screen, the pulse of an ATM, the rhythm of a train, all of it depended on a force they could not see and barely understood, a force that came from beyond the earth itself, from the star that gives us life, but also reminds us, with every flare and every storm, that we are never beyond its reach. As you rest tonight, breathing slow, body still, let that thought drift quietly through you, not to fear it, but to feel the wonder of it, that the same sun that warms your skin and lights your world also breathes storms into the solar wind. Invisible, ancient, indifferent. And that we, in all our brilliance, still live by its grace. The grid may hold today, but tomorrow, when the sky cracks open again, will we be ready? Sleep well, for the lights are still on for now. Above the hum of cities and the silence of far-off deserts, far beyond the grasp of storms and seasons, there are people who spend their lives watching the sun, not watching in the way. We look up to enjoy its warmth or shield our eyes at its glare, but watching with intention, with precision, with a quiet reverence that borders on obsession. These are solar physicists, space weather forecasters, magnetosphere analysts, people whose days are dictated by rhythms that stretch millions of miles beyond our world. By loops of plasma and twisting magnetic fields, by pulses of light that began their journey from the sun's core hundreds of thousands of years ago, before reaching the surface in a burst of brilliance. They are the watchers, the early responders to a kind of natural danger that most of us will never see coming. Their instruments are quiet, but they reach far satellites orbiting in the void between planets, observatories perched high in the mountains, where the air is thin and still, and solar telescopes so finely tuned that they can track sunspots the size of continents. They measure solar flux, coronal loops, radio emissions, and X-ray intensities. They analyze the shape of solar prominences and the complex, shifting magnetic topography of the photosphere. They read the sun like a detective reads a crime scene. Not for what is obvious, but for what is hidden. A sudden tilt in a magnetic loop, a flash of energy at the edge of a sunspot, the faint precursor signals of something building beneath the surface. Most days are quiet. Most flares are small. Most CMEs travel away from Earth and dissolve harmlessly into space. But every so often, there is something different, a signature that sends quiet ripples through the scientific community. A long-duration event. A flare with an impulsive spike and a shockwave traveling faster than theory says it should. A coronal mass ejection shaped like a halo, a full ring expanding outward in all directions, meaning it is coming straight at us. When that happens, phones ring at midnight in the homes of specialists scattered around the world. Emails fly between agencies, governments, satellite operators, and power grid managers. Alerts are sent to pilots and astronauts, to oil pipeline controllers and radio broadcasters. And somewhere in the deep silence of space, the storm begins its journey. From the surface of the sun to Earth takes time, not much, but enough, about 15 to 18 hours for a fast CME, sometimes up to 2 days for a slower one. That window is what scientists use to model its arrival, to estimate its speed, density, and magnetic polarity. Because not all solar storms are dangerous. The sun is always erupting, always pulsing. What matters most is how that energy is shaped. The magnetic field of the storm is aligned in a certain direction, southward, opposite Earth's. It can breach our planet's defenses like a key turning smoothly in a lock. If it's aligned differently, it may glance off, its fury deflected back into space. That small difference, invisible to the eye, can mean the difference between a beautiful aurora and a global disaster. The watchers don't just observe, they model, they simulate the magnetosphere, the ionosphere, the thermosphere, every layer of interaction between solar energy and our protective shield. They track not just the flare, but the shockwave that travels ahead of it, the high-energy particles that arrive in minutes, and the slower, more massive plasma cloud that follows. Their tools are numerical, equations pulsing through supercomputers, forecast models updated in real time, heat maps of geoelectric potential over continents, charts that look abstract to most, but to them speak the language of warning. And when a major event is detected, the gears of global defense begin to turn. Power grids are alerted to reduce load and reroute transmission paths, minimizing the risk of transformer failure. Satellites are put into safe modes. Flights are diverted away from polar routes where radiation levels may spike. Submarines adjust communication windows. In space, astronauts retreat to shielded compartments. On Earth, some governments run drills, test emergency systems, and prepare for outages, though not all take the threat seriously, and many remain underprepared. Because even though we can watch the sun, we cannot stop it. We are observers, not masters. And while space agencies like NASA, ESA, JAXA, and others invest heavily in monitoring tools like the Solar Dynamics Observatory, the Parker Solar Probe, and the European Space Agency's Solar Orbiter, the truth is, solar storms remain unpredictable in their full scale and timing. We can improve forecasts, yes. We can study historical patterns, build better models, launch more sensors. But we cannot see into the heart of the sun. We cannot know when the next Carrington-class event will strike. And so we wait, and we watch and quietly. Some wonder if we are doing enough because modern society is more vulnerable than it was in 1859 back then. Telegraph wires caught fire. Today, it would be data centers, transformers, satellites, aviation routes, supply chains. The risks are broader, the dependencies deeper, the interconnections tighter. A single point of failure in the right location could cascade across entire sectors. And although mitigation strategies exist, hardened infrastructure, grid segmentation, redundant systems, they are not implemented everywhere. Often the cost is deemed too high, the probability too low. Until it is not, some scientists have pushed for international solar storm readiness plans, like earthquake preparedness, before the skies, a protocol for what to shut down, when to power down, how to communicate in a blackout. A universal language of warnings, like the S1 to S5 scale for solar radiation storms. A system of response that reaches not just scientists and governments, but the average citizen. But awareness is still low. The watchers see the storm before anyone else. But the message must travel fast and reach wide if it is to make a difference still. Progress continues. The Parker Solar Probe has flown closer to the Sun than any spacecraft in history, diving through the outer corona and gathering data that could revolutionize our understanding of solar wind and storm triggers. It feels the heat directly, senses the particle flows, reads the changes in magnetic structure as they unfold in real time. And in doing so, it brings humanity closer to the heart of our star, not just physically, but in understanding we are beginning to see the Sun not just as a source of light, but as a complex, living system, a turbulent sphere of plasma and magnetic tension that breathes energy into space like a heartbeat. When with each mission, each breakthrough, we learn a little more about its moods, but understanding does not mean controls their will. Always be an element of chance, a flare erupting without warning, a CME striking just as we approach solar maximum. A quiet night turns suddenly electric. The watchers of the Sun are not fortune tellers. They are guardians, interpreters of a cosmic language that is still being deciphered on every time a flare is tracked, every time a warning is issued in time. A little part of civilization is spared, and we all go on a little longer under the illusion that we are safe as you rest tonight. Remember this, that high above you, even now, there are eyes on the Sun. There are people listening to its frequencies, studying its outbursts, measuring its pulse. They do it not because they can stop it, but because they know that warning is everything. And that sometimes knowledge alone is what stands between calm and catastrophize. Leap well, for someone is watching. The sky and the storm is not yet here. High above the clouds, far beyond the reach of jet streams and commercial flight paths, Earth wears a hidden armor. It's invisible to the naked eye, yet absolutely essential to life as we know it. This armor isn't made of metal or stone, but of force, a vast, dynamic, magnetic field that stretches out into space like a shield, deflecting and redirecting the solar wind that constantly blows from our star. This magnetic field is our planet's quiet defender, the guardian of our atmosphere and the keeper of our most delicate systems. And every time a solar storm approaches, it is here, in this silent region of energy and particles, that the real battle begins. The field is not static, nor is it simple. Earth's magnetic shield, known as the magnetosphere, is a constantly moving, stretching, vibrating structure. It begins deep underground in the molten metal of Earth's outer core, where convection currents of liquid iron generate a powerful magnetic field through the dynamo effect. This field extends outward into space, wrapping the planet in loops and lines of invisible energy. On the side facing the Sun, it compresses under the force of the solar wind. On the night side, it stretches out like a tail, sometimes hundreds of thousands of kilometers long, forming a magnetic cloak that dances with solar energy and shields the atmosphere from cosmic radiation. But when a coronal mass ejection arrives, carrying billions of tons of plasma, magnetic fields twisted like ropes, and energy levels far above normal, that cloak is tested at first. The outer magnetosphere shudders like the surface of a drum struck by a hammer. The pressure builds rapidly, the shockwave from the solar storm slams into it at supersonic speeds, compressing the dayside magnetic field and transferring energy into the system. That energy doesn't just bounce off. It flows in, penetrates, and begins to swirl. This is where the story becomes electric, because the magnetosphere is not just a shield, it is a conductor. And as the solar storm injects energy into its outer regions, the magnetic field lines begin to twist and snap, a process known as magnetic reconnection. This phenomenon, one of the most powerful in plasma physics, allows solar energy to enter Earth's system in concentrated bursts. Particles are accelerated, fields realign. Vast loops of plasma are pulled into new shapes and flung down into the plea. This phenomenon into the upper atmosphere near the poles. That's when the skies come alive, auroras. The northern and southern lights are not just beautiful displays of color. They are the visible signs of this energetic conflict. High-energy particles from space follow magnetic field lines down toward Earth's poles, colliding with atoms of oxygen and nitrogen in the upper atmosphere. These collisions excite the atoms, causing them to glow. Green from oxygen, red from nitrogen, sometimes blue or purple, depending on altitude and density. What looks like magic to the eye is, in fact, a byproduct of Earth's magnetic defense absorbing the sun's fury and transforming it into light. But not all of the energy is harmlessly released as color in the sky, as if it surges through the system in less visible, more disruptive ways. As currents of charged particles move through the ionosphere, the electrified layer of the upper atmosphere, they induce secondary currents down on Earth's surface. These geomagnetically induced currents, or galaxies, can flow through power lines, pipelines, and undersea cables. When strong enough, they can overwhelm transformers, short-circuit circuits, and shut down entire electrical grids. The magnetosphere is like a sponge. It absorbs, it vibrates, it releases, but when the storm is too strong or when our systems are too vulnerable, the consequences spill into our world. GPS signals begin to drift. Radio communication weakens. Satellites experience sudden anomalies or enter safe mode. Oil pipelines see unexpected corrosion from induced currents. Airline routes near the poles are rerouted due to increased radiation exposure. And in extreme cases, transformers overheat and fail, as happened in Quebec in 1989 during a storm that plunged millions into sudden darkness in the middle of a freezing March night. All of this from the shimmer in the auroras to the silent failure of satellites is part of a chain reaction that begins 93 million miles away and ends in the sky above our heads, and yet we rarely think about it. This hidden, humming region of our planet, the magnetosphere, is always working, always shifting. It's not solid, not unbreakable, but it is resilient and incredibly responsive. When calm, it flows like a stream. When stressed, it crackles like a storm. It is a reminder that even the ground beneath our feet is not as solid as we imagine. That the Earth is not just a planet, but a node in a larger cosmic system, linked to the rhythms of a star that burns with both life and danger. Scientists study the magnetosphere with satellites like Themis, Cluster, and the Magnetospheric Multiscale mission. These spacecraft fly in formation through this field of force, taking measurements of particle density, magnetic flux, and electric fields. They are like scouts in the invisible war above, sending back data that allows us to model, understand, and when necessary, protect ourselves from what's coming. And it's not just big storms that matter, Vin. Small solar disturbances can have subtle effects, a few milliseconds of GPS delay, a small shift in satellite positioning, a bit of added drag on spacecraft orbiting low above the Earth. Over time, these can add up. Pilots flying polar routes sometimes report strange compass deviations. Astronauts in orbit experience increased radiation exposure during certain events. And radio operators, especially those using long-range, high-frequency communication, often adjust their strategies to avoid the blackouts that can occur when the ionosphere is disturbed. It is a system of domino solar flare coronal mass ejection shockwave reaches. Earth magnetosphere compresses field lines, snap particles, accelerate auroras, glow currents. Surge infrastructure trembles, and through it all, our technologies, our lights, our maps, our networks ride the edge between stability and collapse. But even as the risks remain, so does the wonder, because the same forces that threaten us also create the most beautiful natural light shows on Earth. The same energy that stirs up transformers also paints the night sky with curtains of green, red, and violet that dance across the northern latitudes. What threatens our power grids also ignites the atmosphere with a whisper of cosmic poetry. Tonight, while you rest, Earth's magnetic shield is hard at work, flowing, bending, deflecting, keeping you safe from a storm you'll never see on somewhere. Above, auroras ripple quietly over the polar skies, writing stories of solar fire and planetary resilience in the language of light. Imagine holding a compass in your hand, watching the needle twitch, hesitate, and then begin to swing, not toward the north as you've always known it to do, but south. Not just a brief error, not a broken instrument, but the beginning of a profound transformation unfolding beneath your feet. This isn't a science fiction concept or a distant hypothetical. It's a very real possibility, one written into the history of our planet, not once or twice, but dozens of times. Earth's magnetic field, the same shield that protects us from the sun's constant storms, is not fixed. It has reversed itself, flipped many times over the last few million years, and scientists believe it could happen again. The question is not if, but when. And what might it mean for civilization when north becomes south and the invisible forces that guard our world begin to shift? To understand why this matters, we need to travel deep below the surface of the Earth, beneath the crust. Far below the continents and oceans lies the molten outer core, a churning ocean of liquid iron and nickel, nearly as hot as the surface of the sun. It is here, in this swirling metallic sea, that Earth's magnetic field is born. The motion of this conductive fluid generates electric currents. Those currents in turn create a magnetic field, a self-sustaining cycle known as the geodynamo. But this system is not perfectly stable. Like weather in the sky, the flow of the outer core can change over time, creating eddies, reversals, and fluctuations in the field it produces. Sometimes, those fluctuations become extreme over thousands of years. The magnetic poles wander. The North Magnetic Pole, for example, has been moving rapidly across the Canadian Arctic, heading toward Siberia at a pace of more than 50 kilometers per year. And in the past, it hasn't just wandered, it has flipped completely. In what geologists call a geomagnetic reversal, the entire magnetic field of the Earth weakens, fragments, and then rebuilds itself in the opposite orientation. North becomes south, and vice versa. The last time this happened was about 780,000 years ago in what's known as the Bruns-Matsu-Yama reversal. But evidence from volcanic rocks and ocean sediments suggests that reversals have occurred roughly every 200,000 to 300,000 years over geological time. We are, in other words, overdue. But this isn't a sudden switch. Like flipping a light, the process of reversal is slow and complex. It could take hundreds or even thousands of years to unfold. During this time, the magnetic field doesn't simply rotate, it weakens, sometimes to as little as 10% of its normal strength. It fragments into multiple poles. The structure becomes chaotic, unpredictable. Regions that once had clear magnetic orientation might experience magnetic anomalies, with compasses spinning wildly or pointing in strange directions. Navigation systems that rely on the magnetic field would become unreliable. Birds, whales, and other migratory animals that use Earth's magnetism to navigate could become disoriented. Even more concerning, the weakened field would allow much more solar and cosmic radiation to reach the Earth's surface. That's where the connection to solar storms becomes critical. Weakened magnetic field means a weaker shield. And during a reversal, Earth could be more vulnerable to the effects of solar flares and coronal mass ejections. The magnetosphere, already stretched thin by the force of solar wind, could become porous. Charged particles might penetrate deeper into the atmosphere. Satellite systems could be more easily disrupted. Power grids might face greater risk from geomagnetically induced currents. And the auroras, though silent, shimmering signs of solar activity, could begin appearing at much lower latitudes than ever before, painting the skies above cities that have never seen such light. But there is more than one way the magnetic field can change even without a full reversal. The field can undergo what's known as an excursion. a temporary weakening or deviation that does not result in a complete flip. One such event, the Lashams excursion, occurred about 42,000 years ago and lasted for several centuries. During that time, the magnetic field weakened dramatically, and some researchers believe this may have had significant effects on climate, biology, and even human behavior. Increased radiation exposure, shifting atmospheric currents, and auroral activity visible across much of the planet may have contributed to widespread environmental and cultural changes. Today, satellites and ground stations monitor Earth's magnetic field constantly. They measure its strength, its shape, its fluctuations. And what they show is both fascinating and a little concerning. Over the last century, the field has been weakening. The South Atlantic anomaly, a region of particularly weak field strength over South America and the South Atlantic Ocean, has been growing and deepening. This anomaly poses problems for satellites that pass through it, which often experience data corruption or hardware malfunctions due to the increased radiation exposure. Some scientists believe this may be an early sign of a developing reversal. Others caution that such anomalies have occurred before without leading to a full flip. Still, the data is clear. The field is changing. What would life look like during a magnetic reversal? The sky would glow more often, with auroras drifting far beyond their normal polar ranges. Navigation systems, from simple compasses to aircraft instrumentation, would need constant recalibration. Power grids would need reinforcement. Communication systems, especially those relying on high-frequency radio waves or satellite relays, would need to be redesigned to handle more frequent and intense disruptions. There might be an increase in radiation exposure for passengers on high-altitude flights or for astronauts in orbit. And in the long term, the increased energy reaching the atmosphere could subtly alter climate patterns, triggering changes in wind, precipitation, or storm behavior that ripple through ecosystems and food systems. And yet, Earth has survived every reversal before it. Despite the dramatic shifts, there is no evidence that magnetic reversals have caused mass extinctions. Life endures, civilizations adapt, technologies evolve. And the field, after its long wandering journey, eventually itself solidifies and strengthens once more. In fact, if you didn't have instruments to detect the magnetic field, might not notice a reversal at all, just the strange behavior of compasses, the more frequent auroras, and perhaps a slight increase in radiation-related phenomena. Still, the possibility forces us to ask larger questions. What anchors us to certainty? What hidden forces guide us, even when we can't see or feel them? The magnetic field is not something we can touch. It doesn't make noise. It can't be seen with the eye, and yet it holds our systems together. It quietly protects the upper atmosphere. It helps birds fly home. It keeps our satellites working and our maps accurate. It is, in many ways, a kind of planetary subconscious, always working, always shifting, always influencing. When the poles flip, that subconscious rises into awareness. We begin to notice the invisible. We begin to see that our planet is alive in ways we often forget. That beneath the soil, a river of molten metal flows and turns, generating not just heat, but order. Not just magnetism, but meaning. And when that order unravels, even slowly, even silently, we are reminded of how fragile and how wondrous our systems truly are. Tonight, as you fall asleep, somewhere far below, the Earth's core is turning, and, above, the magnetic field stretches out like a glowing net, holding back the solar wind, guiding particles through polar skies, humming softly with the echoes of a star that never stops burning. And if one day the needle swings south and the sky shimmers over cities that have never known auroras, we'll remember that Earth has always changed. We are part of its rhythms, no matter which way the compass points. Some threats come with noise, sirens, or flashing lights. Others come quietly, disguised as beautiful skies or invisible fields of energy. Solar storms belong to that second kind, events so silent they can slip across space at millions of kilometers per hour, reach our planet in hours or days, and unsettle everything we've built without making a sound. In the past, they disrupted telegraphs and flickered lights. Today, they can disable satellites, scramble GPS, and threaten the electrical web that keeps our world humming. But what about tomorrow? What would it take to build a civilization that isn't vulnerable to the moods of the sun? Can we defend against the next great solar storm, or must we learn to live with the risk, accepting that some forces will always be beyond our control? To understand what's at stake, we need to remember just how much our world depends on electricity, from the moment we wake to the moment we fall asleep, and even while we sleep. Electrical systems quietly serve us. Power grids keep hospitals running, traffic signals blinking, water pumping, data flowing. Satellites orbiting above carry our calls, navigate our vehicles, forecast our weather. All of it, every signal and circuit, depends on a stable, protected system. And all of it is vulnerable to the sun, a sufficiently large coronal mass ejection. Acme can disturb Earth's magnetic field so deeply that electrical currents are induced in long conductors like power lines, pipelines, and undersea cables. Transformers can overheat. Satellites can be fried. Navigation systems can fail without warning. And while short blackouts might be inconvenient, long ones can unravel modern life in ways we've barely imagined. That's why researchers and engineers have begun to ask a new kind of question, not just how do we predict solar storms, but how do we build systems that survive them? The answers begin in space. High above Earth, new satellites are being designed to watch the sun constantly. With eyes tuned to its flares, plasma eruptions, and magnetic shifts, instruments like NASA's Solar Dynamics Observatory and the European Space Agency's Solar Orbiter are collecting real-time data to better understand how solar storms form and how they travel. The goal is simple but profound. Earlier warnings. If we can detect Acme shortly after it erupts from the sun, we may have 12 to 48 hours to prepare to shut down vulnerable systems, reroute flights, power down satellites, and protect the infrastructure that matters most. But warning alone isn't enough. We also need resilience, systems built not just to run smoothly, but to endure disruption. Power grids can be redesigned with smaller modular transformers that are easier to replace. Grounding systems can be improved to handle the strange electrical surges created by geomagnetic storms. Satellite hardware can be hardened against radiation, and networks, the invisible highways of the internet, can be built with more redundancy so that if one path fails, others can keep the signal flowing. In some countries, these ideas are already being tested. Norway and Canada, for example, monitor their grids closely for geomagnetically induced currents, especially during periods of heightened solar activity. Space weather forecasting centers have begun issuing alerts, much like they do for hurricanes or tsunamis. Still, challenges remain. One of the hardest truths about solar storms is how unpredictable they can be. The sun doesn't run on our schedule. Its cycles, roughly 11 years from minimum to maximum, guide its behavior, but not precisely. Some cycles are quiet, others violent. And even within a single cycle, a massive storm can erupt with little warning. It's like watching a bonfire from across a field. You can see the flames, feel the heat, but you can't always tell which way the sparks will fly. This unpredictability means we must design our civilization not just to react, but to anticipate. To assume that the sun will flare again, perhaps even tomorrow, and to build not out of fear, but out of foresight. And there is another layer, a deeper, quieter kind of defense education. Awareness. The more we understand the sun and its cycles, the less helpless we feel. Schools can teach space weather alongside Earth weather. Emergency planners can include solar storms in their risk scenarios. Individuals from pilots to power station workers can learn the signs of a solar event and the protocols that teach its size. Keep them safe. In many ways, knowledge is our first and best line of defense. The sun will always be powerful. But power alone doesn't have to equal danger, not if we learn to live in rhythm with it, instead of pretending it cannot touch us. Looking further ahead, some visionaries imagine even more radical approaches. Could we someday build satellites that shield Earth from solar storms? Could we deploy massive solar sails that deflect plasma clouds? Could we create smart grids that adapt in real time, rerouting power and isolating affected zones with the flicker of an algorithm? These ideas may sound distant, and they are. But consider this. A century ago, people laughed at the idea of controlling fire from a pocket or sending images through the air. Now we carry smartphones and stream movies from space. The future is not bound by our present limits. It grows from imagination, seeded by necessity. But the deepest lesson may be this: fragility can lead to wisdom. It's easy to think of civilization as permanent, sturdy, invulnerable. But solar storms remind us that even the invisible can shake us. Even the sky, that vast, quiet ceiling, holds forces we cannot command. And in that recognition, there is something beautiful. We are not above nature. We are part of it. The sun that feeds our crops and warms our days is the same sun that hurls plasma across space. And in learning to adapt to respect that balance, we grow wiser. Tonight, as your thoughts slow and the world darkens around you, remember this: of the clouds, the sun still burns. It spins, it flares. It breathes radiation and plasma into the emptiness. But here on Earth, we learn, we watch, we build, and slowly we shape a world that bends but does not break. A world that listens to the stars, not with fear, but with quiet readiness. Because to survive the sun is not just a matter of shields and wires and switches. It's a matter of remembering how small we are, how clever, how sometimes the oldest force in the sky teaches us the newest truths. There is a kind of silence that does not soothe you, but unsettles you in the strangest way. It is the silence that follows a blackout. No hum from the refrigerator, no buzz from streetlights, no low electrical hum that usually runs beneath our modern lives like a hidden song. In that stillness, we begin to hear the world as it truly is. Trees creaking softly, birds shifting in their sleep, and the quiet weight of our own breath. Now imagine that same silence spreading across an entire continent. Imagine city after city dimming out, street by street, country by country, until the whole map of civilization flickers and fades. That is what we are about to imagine now. A blackout, not just in one town or one country, but a blackout that circles the earth, the kind that could come from the sun itself. In this part of our story, we're going to walk through a global simulation, a carefully crafted and scientifically grounded scenario of what might happen if a massive solar storm, one far stronger than any we've experienced in the modern age, struck Earth directly. This is not fantasy. It is based on historical events, on projections from space agencies, and on the delicate systems we use every single day without thinking. Tonight, we'll watch the world go dark, not in panic, but in quiet thoughtfulness. We'll trace each domino as it falls, and perhaps, by the end, we'll understand how fragile and miraculous our connected world truly is. It begins with the sun. A massive sunspot appears on its surface, visible through specialized telescopes as a dark whirl the size of Jupiter. Space agencies begin to monitor it closely. There have been flares from this region before, some strong enough to affect shortwave radio on Earth. But today, something far more powerful happens. A coronal mass ejection, ACME, erupts violently from the sun's surface, hurling billions of tons of charged particles into space. These clouds of solar plasma are not uncommon, but this one is different. It is moving fast, and it is aimed directly at Earth. Scientists have between 12 and 24 hours to prepare. Satellites detect the oncoming storm. Observatories across the planet confirm its trajectory. Governments are notified. Some precautionary steps begin immediately. Satellites are put into safe mode. Power companies are warned. But predicting the exact strength of the storm is notoriously difficult. Many CMEs miss the planet. Others arrive with less force than expected. But this one does not. When it arrives, the skies above the northern and southern hemispheres explode into color. The auroras, usually restricted to the poles, spread as far south as Texas, Spain, and northern India. Curtains of green, pink, violet, and red ripple across the sky like a living ocean. At first, people stare in awe. Cameras flash. Social media floods with videos. It feels like a celestial light show, something beautiful and rare. But below the surface, deep within the Earth's crust, electric currents begin to flow. These are geomagnetically induced currents. Powerful surges that move through rock and soil and metal. They follow pipelines, railroads, power lines. They enter transformers and disrupt their function. In Quebec, just like in 1989, the power grid begins to falter. But this time, it spreads. Power stations across the eastern United States go dark. In London, strange voltage spikes knock out regional substations. In Japan, automated shutdowns ripple through the smart grid. Within minutes, millions of homes lose power. Within hours, it becomes clear this is not a localized event. A continent-wide blackout is underway. Emergency services begin switching to backup generators. But the chaos is not limited to the ground. In orbit, dozens of satellites are affected. Some are permanently disabled. Others spin out of alignment. GPS systems begin to fail. Planes in midair are rerouted using voice communication only. Maritime traffic loses its navigational systems. Across the globe, the precision web of satellites we rely on begins to fray. By morning, the world has changed. Electric power is out across most of North America, large parts of Europe, portions of Asia, and even sections of Australia. Cell towers fail. Internet service disappears. Banks close. Credit card systems no longer work. Gasoline cannot be pumped. Emergency broadcasts are patchy and inconsistent. Governments begin to address the public using whatever means they still have: radio stations, loudspeakers, printed flyers. The word they use is temporary, but no one can say for how long. In hospitals, emergency generators begin to run low on fuel. In cities, water purification systems start failing. Some communities boil water using fires or gas stoves, but many do not have the means. Supermarkets lose refrigeration. Perishable food spoils. Only those with cash can make purchases, and even then, the choices dwindle quickly. In rural areas, some people are better prepared. They have wood stoves, wells, and gardens. But in cities, the panic begins to grow. Traffic lights do not work. Public transportation systems stop. Trains are stuck between stations. Subways are abandoned. Emergency responders do their best, but communications are sporadic. Each region becomes a pocket of its own reality. Some organized and cooperative, others chaotic and afraid. People light candles. They cook food quickly before it spoils. They try to call loved ones, but more often than not, the phones are silent. Day 2 arrives with questions no one knows how to answer. How long will it last? How many systems were affected? Will the power come back soon? Behind closed doors, scientists and engineers work tirelessly to assess the damage. Transformers have melted. Transmission lines have fused. Some parts of the power grid are physically destroyed. Replacing these components is not a matter of hours or days. It could take weeks. For some areas, even longer. Supplies are limited. Skilled workers are stretched thin in space. The solar storm continues. More particles arrive. The magnetic field bends and flexes. The auroras continue, more intense than ever, glowing even at noon in some places. People gather outside at night, staring upward. Some cry, some pray. Others sit in silence, feeling the strange pull of something ancient. The realization that the universe is still wild and vast and full of power beyond our control. By the end of the week, the world settles into an uneasy rhythm. In the absence of digital systems, analog ones return. Printed newspapers are delivered on foot. Chalkboards announce community meetings. Bicycle messengers deliver notes between neighborhoods. People begin to share food, water, tools. They gather in common spaces. They start fires in parks. They take care of one another. The hardship is real, but so is the cooperation. In many places, what rises is not chaos, but community. Yet in other places, the story is darker. Looting begins. Not from evil or greed, but from fear. People break into stores for formula, for medicine, for food. Police try to maintain peace, but resources are limited. Without electricity, surveillance systems do not work. Prisons struggle to maintain security. Some cities declare a state of emergency. Others simply close their borders by the second week. The first signs of recovery begin. Solar panels in some areas continue to generate power. Microgrids are formed. Portable generators are shipped from unaffected regions. Engineers begin to restore isolated parts of the grid. But the process is slow and painstaking. Every connection must be tested. Every damaged transformer must be replaced. Countries that had stockpiled backup parts recover faster. Those that did not wait longer. Scientists hold press conferences. Explaining what happened, they show solar imagery. They explain the chain of events. They warn that another storm could come. They emphasize preparation, resilience, the need for better shielding, better planning. For many people, it is the first time they have ever heard the term space weather, and they never forget it. A month later, most power is restored. But the world is not the same. There is a new awareness now. People stock food and water. They install radios. They plant gardens. Governments invest in hardening infrastructure. Schools teach children about solar storms. The fragility of civilization is no longer a theory. It has been lived and remembered, and even long after the lights return. People look differently at the sun. They watch it rise each morning with a new kind of respect, not fear, but reverence. It is not our enemy. It is our source of life. But it reminds us, sometimes violently, that we live in a cosmic neighborhood filled with forces greater than our understanding. So as you lie there now, beneath your blanket, listening to the quiet sounds of your room, think of the silence that once blanketed the earth, not a silence of endings, but one of reflection. A silence that taught us how connected we are, how vulnerable, and how strong we can become when we remember that connection. Breathe in, let your thoughts drift, and sleep peacefully, knowing that even when the lights go out, we carry our own light within us. And when the sun sleeps, we wait. And when it wakes again, so do we. Every civilization has a memory, though it is not stored in any one person's mind. It lingers in stories, in monuments, in scars we cannot always name. And when something profound happens, something that changes not just individuals, but entire societies, that memory becomes part of us. Like the feeling of heat from a fire that no longer burns, it remains in the bones of our culture, quietly shaping how we build, how we dream, and how we prepare for what may come again. Tonight, as we close the final chapter in this quiet unfolding of cosmic cause and human effect, we reflect not on disaster, but on legacy. What remains after the storm passes? What lessons linger in the soft dark once the skies have settled and the wires begin to hum again? The solar storm we imagine together, though fictional in its timing, is entirely real in its possibility. Experts in astrophysics, atmospheric science, power infrastructure all agree that events like this have happened before and will happen again. But as we follow the trail of this story into its last hours, we shift from the chaos and collapse to something far more enduring. We look now at what comes after the sky cracks open. What is rebuilt? What is remembered? What becomes sacred in the stillness? Months have passed since the lights went out. Most cities have power again. Planes fly, phones ring. Refrigerators hum quietly in kitchens where families now cook more together. And yet, everything feels just a little different. The solar storm, like a great breath from the universe itself, did not destroy civilization, but it woke something in us. A sense of scale, a sense of humility, and for many, a strange new reverence for the invisible systems we take for granted. People talk more now, face to face, without a screen between them. Children who once stared at tablets for hours now climb trees, help in gardens, and ask questions about the stars. Communities that were forced to live without electricity for weeks discovered something rare and powerful: the art of presence. Neighbors who had never met began sharing meals. Strangers helped one another charge devices with car batteries, carried water up apartment stairs, watched over each other's children. In many places, these bonds did not fade after the lights returned. They grew. Churches, libraries, and schools became centers not just for learning, but for memory. People gathered to tell their stories, to preserve the shared experience of the Great Blackout, and to remind one another what truly matters. Governments around the world took notes as well. Reports were written, commissions formed. Satellites were retrofitted. New shielding protocols were drafted. And perhaps most importantly, the idea of space weather entered the public conversation in a way it never had before. No longer an obscure topic for scientists alone, it became part of the larger understanding of how we live and how we might survive again. Agencies proposed backup grids, more localized power sources, and global coordination strategies for solar events. What had once been theoretical now felt deeply personal. But beyond the politics and power lines, something quieter changed too. A cultural shift, barely spoken but deeply felt. People began to wonder about the cosmos in a more intimate way. Just as a source of beauty or wonder, but as a living environment, one that could reach across the void and touch us in ways we were not prepared for. The sun, once viewed only as a giver of light and warmth, was now seen as a force that could also stir the Earth's core, bend magnetic fields, and silence cities. It was not malicious, not angry, simply powerful. And that power inspired awe. Artists painted vivid auroras on city walls, reminding the next generation of the colors that once danced above their rooftops. Poets wrote verses about the skies. Silence, children reenacted the blackout during school plays, and, in remote places, far from the noise of urban life, families sat around campfires and told stories of the time when the sky came alive and the earth went still. For some, it became almost mythic, not in the sense of exaggeration, but in meaning. The blackout had become a modern parable about fragility, connection, and the hidden threads that bind us to the stars. And what of science? What of the pursuit? To understand, to predict, to prepare. It continued, as it always does, but with renewed urgency. Solar observatories were upgraded. New satellites launched, simulations refined. There was a shared understanding now that solar storms were not distant curiosities, but tangible, trackable events that could shape economies, communities, and histories. Universities added courses on heliophysics. Emergency planners factored space weather into their models. Slowly, cautiously, Humanity became a little more solar-literate, but not everything that changed was written in policy or ink. Some changes were invisible, internal. A mother who now keeps a crank radio by the window, just in case. A child who stares longer at the morning sun, wondering what secrets it holds. A teenager who decides to study electrical engineering after watching a transformer explode during the storm. A farmer who installs a manual pump beside his electric one. These are not grand revolutions, but quiet revolutions, the kind that shift us from the inside. We often think of disasters as endpoints, but in truth, they are thresholds. They open doors that were closed, illuminate flaws we never saw, and remind us that resilience is not found in perfection, but in adaptation. The solar storm did not end civilization. It revealed its edges. And in doing so, it gave us the chance to smooth those edges, to fortify them, to imagine something stronger in their place. In spiritual communities, new rituals emerged. Some people gather at sunrise now to offer gratitude to the sun, not in worship, but in respect. They acknowledge the delicate balance that keeps the earth shielded, the magnetosphere intact, the systems humming. They light candles not out of fear, but out of reverence for light itself, for its presence and its sudden absence. They remember the auroras not as a warning, but as a gift, a moment when the heavens revealed their true depth. And now, as our story draws to a close, we find ourselves back where we began, beneath the sky, listening, not just to the stars or the winds or the whispers of scientific data, but to our own memory, to the part of us that knows, deep down, that we are connected not just to one another, but to something far larger, something cosmic, something alive. So, as you lie there now, in your bed, in your room, wherever you are, with the lights dimmed or off, your phone set aside, your mind beginning to slow, take a moment to picture the Earth from space. A quiet blue world wrapped in invisible shields, a place of cities and farms and oceans and dreams, a place that dances in the sunlight, spins in the shadow, and occasionally pauses to remember how small and strong it really is. And think of the sun, our star, not just a source of heat, but a reminder of the great unfolding mystery we call the universe. Think of its flares, its pulses, its deep rhythms we have only just begun to understand. Think of how something so far away can reach into our lives, rearrange our habits, teach us humility. Breathe in, slowly. Let your thoughts drift. You are part of this cosmos. You carry stardust in your bones. You ride the earth as it orbits through invisible fields. You listen to stories that connect sky to soul. And even when the sky cracks open, you remain. Thinking, dreaming, resting. Thank you for spending these nights with us. Thank you for following this quiet storm, this journey from silence to memory. Sleep well, stargazer. Sky is calm tonight, and you are safe beneath it.